In this video, we are going to look at the infinite one-sided limits, or another way we call it unbounded one-sided limits. If a limit is indicated to be either positive infinity or negative infinity, then it does not exist, or we use the term like D and E. These symbols are used only to indicate the direction of the unboundedness or infinity. Let me get the marker. Like grow without bound, something like that. The direction, like positive side or negative side. Positive side, that means going all the way up. Negative side, go all the way down. Basically, the direction. So, for the first part, like positive infinite limit, if the function f of x increases, note that the f of x is the same as the y value when y is increases without bound, or y approaches infinity. That's what it means. As x approaches a from the left, this part, the notation, as you recall, x approaches a from the left superscript negative side, or from the right. From the right, that means x approaches a from the right or superscript plus side. Then we say that f of x approaches positive infinity, or in the positive direction, like increases, going up. The notation, sorry for the cutoff here. So basically it is the limit f of x as x approaches a from the left equals positive infinity. Another way, when x coming toward to the a from the left side, like x is less than a, the y increasing without bound, y approaching infinity. Similarly, this one, the limit f of x as x approaches a from the right equals positive infinity, or when x coming toward to the a from the positive side, or x is slightly greater than a, and the y increases without bound or approaches positive infinity. Another case, the case that with the negative infinite limit, this time increasing, the direction is in the negative way. So when y value, or the f of x, decreasing without bound, that is about like infinity, going down like negative sign, x approaches a from the left, again x approaches a superscript negative side, from the right x approaches a positive side, then we say f of x approaches negative infinity. And then we can see this one, this graph represent the limit of the function f of x as x approaches a from the left side equals negative infinity, because as you see the flow of the graph here, x coming toward to the a, but x still less than a, so that's represent the negative side or the left hand limit. The y value decreasing without bound or approaching negative infinity, where the right graph represents the limit of the function as x approaches a from the right is negative infinity. The trend of the graph, like as x coming toward to the a, or x is slightly greater than a, the y value is decreasing without bound or go toward to the negative infinity. Next, we're gonna look at the example. From the graph provided, we find a one-sided limit of the function at different points of a here. For part A, x approaches negative 1 from the left, x approaches negative 1 from the right. For part B, and C and D are similar, like approaches 3 from the left and from the right. So for part A, x approaches negative 1 from the left, so that means x is slightly less than negative 1, where part B, x is slightly greater than negative 1. Part C, x slightly less than 3. Part D, x slightly greater than 3. And then we're going to look at the trend of the function value or the direction of the function value or the y value. Okay, let's start with -1. So -1 is right here. In part A, we look at the left-hand limit because negative side. So we look at the left part of the graph. As x approaches -1 from the left, the function value of the y approaches to the value 4. Okay, right there. And then the next one, as x approaches -1 from the right side, so coming on the right side, so the right side of the graph here, as you see the arrow goes toward to the bottom, so that means y approaching down to the negative infinity. Then part B, the answer is negative infinity. Part C, x approaches 3 from the left. The 3 is right here. From the left side, we look at the left part of the graph. The graph approaching, increasing without bound, or y approaches positive infinity. So that's the answer for part C. You can ignore plus sign. It's understood to be positive infinity. But the negative side, you cannot miss it. The last one, approaching 3, but this time coming from the right side. From the right side, we look at the right graph. As x approaches 3 from the right, the y approaches to the value 2. So y approaches to the value 2. That's the answer for part D.